Hello students, good morning all of you, and this is your Prabhakar and welcome to my channel Dawn of Chemistry. And today we are going to discuss about the bases. In my previous video I have discussed about the basics of acids. In that we have discussed what is an acid and what are the different types of acids, how to remember the names of acids, and how to identify the strength of acids in different manner. In the same way, in the present video, we are going to discuss about the bases. What is a base basically? What are the generally how to have idea on the total bases available and how to compare the strength of the bases in between them. Let us get into the topic bases. In our lower sections, we have studied a definition regarding this base as any substance that is soapy to touch and bitter to taste is called as a base. That is based on the property. And this base is also called as alkalis. Bases is also called as alkalis. Right. Now come to this thing, bases. These bases, they can convert red litmus into blue litmus. You can remember acids converts blue litmus into red litmus, bases convert red litmus into blue litmus. Here some confusion will be there for everybody. What you do means blue litmus is having blue, so that's why bases will be converting the color into blue. You remember, you can easily identify. Bases converts red litmus into blue, so bases will produce blue color. That you remember, easily you can remember this thing. See, bases are majorly hydroxides. Mostly bases are hydroxides. Mostly these hydroxides are metal hydroxides. Mostly metal hydroxides behaves as bases. As in the case of acids, we have classified them into inorganic acids and then organic acids. In the same way, we can classify the bases also into two categories: inorganic bases and then organic bases. Inorganic bases further can be classified into two categories based on the chemical formula. That is hydroxide bases and then other than hydroxide bases. Hydroxide bases and then other than hydroxide bases. Other than hydroxide bases gas, you can have sodium carbonate, you can be having. Next, organic bases. Organic bases, the best examples are aniline, pyridine, pyrrole, and then amine, like this. So as we have discussed already, no acid will behave as acid always. In the same way, no base will behave as base always. Now let us discuss about this hydroxide bases. In these hydroxide bases, mostly we are having the first A group element hydroxides, second A group element hydroxides, third A group element hydroxides, D block element hydroxides, and then F block element hydroxides. Let us see the first A group elements. We know the first A group elements are lithium, sodium, potassium, rubidium, cesium. For those elements, you add the oxide group. So lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, and then cesium hydroxide. Coming to the second A group elements, beryllium, magnesium, calcium, strontium. Barium are the second A group elements. Simply beryllium hydroxide, magnesium hydroxide. Since their valency is 2 for them, hydroxide valency is 1, you can write this formula. Magnesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. Coming to the third A group elements, boron, aluminium, gallium, indium, thallium. Boron hydroxide, BOH thrice. This is exceptional. This will be acidic in nature. Yesterday I have explained this thing. Aluminium hydroxide, gallium hydroxide, indium hydroxide, thallium hydroxide. So simple thing, the element whatever you want, that element we will take and we will add the hydroxide group to that particular element. Let's come to D block elements. The D block elements we are having is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So scandium hydroxide you can take. But here scandium will be showing two different oxidation states. +1 oxidation state it will show and +3 it will show. Based on that thing it is possible. Titanium hydroxide, vanadium hydroxide, chromium hydroxide, manganese hydroxide. Though it is showing +5 and +7 oxidation state, it prefers to be present in the +2 oxidation state. Iron hydroxide, FeOH thrice, COOH twice, NiOH twice, CuOH twice, ZnOH twice will come. Like this, by using the D block elements you can produce the hydroxides. So these are the theoretically possible hydroxides, and these are theoretically they can exist as the bases. But among these, some of them will be having the amphoteric nature. Among these, some of these will be having the amphoteric in nature. So zinc hydroxides and then aluminum hydroxides behaves as both acids and bases. I will tell you whenever I am explaining you the theories of acids and bases, that time I will give you very great clarity for you people about these amphoteric nature also. For the basic level, you just try to go through this thing. So let us see what we have discussed. I will revise. What are bases? And these bases are also called as the alkalis. Alkalis, mostly they are bitter to taste and soapy to touch. They convert the red litmus into blue litmus. How can you identify how it is converting red litmus into blue litmus paste? Base forms blue color. You can remember like that. Mostly the bases will be hydroxides always. And let us see, these bases are inorganic bases and organic bases. Inorganic bases are classified as hydroxide bases and other than hydroxide bases. The best example for other than hydroxide bases will be Na2CO3 will be coming. See, why Na2CO3 comes means it is a salt of strong base and then weak acid. Since it is a salt of strong base and then weak acid, you can consider this to be a other than hydroxide base also. Next you see Na2C2O4 also you can have like this. And organic bases are aniline, pyridine, pyrrole, and then amine will be coming. And next you see first A group hydroxide, second A group hydroxide, third A group hydroxides, and then D block hydroxide. Sir, how can we compare the strength of the bases? Always remember, the strength of base depends on its capacity to donate the OH group. The capacity to donate the OH group. So let us see how lithium hydroxide is there. The strength of base depends on its capacity to donate the OH group. Let us take lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. So as you move from lithium to sodium, the radius of the atom is gradually increasing. As the radius increases, the bond becomes weak. So that's why basic nature is directly proportional to MOH bond length. So basic nature is directly proportional to MOH bond length. Why it will be directly proportional to MOH bond length means as the OH bond length increases, you can easily break the bond. So that's why it can donate the OH group very easily, and hence it behaves as a base. We can have a small question here. Sir, in the hydroxides, whenever you take any hydroxide like MOH, there is a OH bond also. Yesterday you have told some oxy acids which will be having the OH group. The bond between oxygen and hydrogen will be broken, and so it can donate H plus ion also. That is a possibility. But here you see the possibility. MO bond weak, then OH bond. MO bond is weak bond, then OH bond. That's why first metal oxygen bond will be broken, and hence it will be liberating the OH group. So that is the thing regarding this metal hydroxide. So now see, in the first year group elements or second year group elements or third year group elements, any group you take, on moving from top to bottom, the bond length increases, and hence from top to bottom basic nature increases. So basic nature mainly depends on the bond length between the metal and the hydroxy bond. So that's why basic nature increases. Sir, what about from left to right? Here you see lithium hydroxide is there, beryllium hydroxide is there, and then aluminum, or sodium hydroxide is there, magnesium hydroxide is there, and aluminum hydroxide is there. Which is more basic in nature? You know from the periodic properties, whenever periodic table comes, that time again I will explain in detail about that thing. So see, sodium, magnesium, aluminum. As you move from left to right in the periodic table, the size of the element will be decreasing. As the size of the element will be decreasing, the bond length also will be decreasing. Since the bond length is decreasing, automatically the basic nature decreases. So that's why when you move from sodium to aluminum, basic nature decreases. So as you move from left to right in the periodic table of the hydroxides, their basic nature will be gradually decreasing. Like this, we can explain the strength of first year group hydroxide bases, second year group hydroxide bases, third year group hydroxide bases, and then D block hydroxides bases. Just take down this for 1 minute. So here we have discussed what are bases, how many types of bases are there, what are the hydroxide bases, and how can we compare the strength of the hydroxide bases in first year group elements, second year group elements, third year group elements, and then in case of D block elements. Let me tell you the F block elements also. After that we will come to the nitrogen family bases, how we will be explaining. Hope you have noted this thing. So I am rubbing this thing. that. Now let us see the lanthanide element basis. Lanthanide hydroxide. This one is very important one. Actually, for every student, it is very great challenging topic to identify the lanthanide elements and then actinide elements. I will tell you one mnemonic also. In the next video, I will produce that mnemonic also. For that, easily you can remember. Lifetime you can remember that way. Let's see. Lanthanide elements. What are the lanthanide elements means? Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, ytterbium, lutetium. So see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 will come. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and then lutetium. Here I missed the thulium. See, lanthanum is a D block element. Remember this very carefully. This is very important JEE mains question and NEET question and in national that state eligibility entrance test exams also. So what is this lanthanum? Lanthanum belongs to D block or F block. This is very important question because normally lanthanides will be considering as lanthanum also present in the F block and actinides will be considering them as they are present in the F block elements only. But originally lanthanum and actinum belongs to the which block? D block. Only these elements belongs to the F block. If you see, the hydroxides of them are cerium hydroxide, promethium hydroxide, neodymium hydroxide, promethium hydroxide, samarium hydroxide, europium hydroxide, gadolinium hydroxide, terbium hydroxide, dysprosium hydroxide, holmium hydroxide, erbium hydroxide, thulium hydroxide, ytterbium hydroxide, and then lutetium hydroxide. From cerium to lutetium 3+, atomic radius decreases. From cerium to lutetium, as you move from left to right across a period, the radius of the element will be gradually decreasing, and because of this decrease is because of lanthanide contraction. Why the atomic radius decreases? It is because of the lanthanide contraction. This is one of the consequence of this lanthanide contraction. When you move from cerium to ytterbium hydroxide, the basic nature gradually decreases. Why the basic nature gradually decreases is because from cerium to lutetium, atomic radius will be gradually decreasing, and hence the holding of the lutetium oxygen bond will become strong, and hence the basic nature decreases. So that's why cerium hydroxide to lutetium hydroxide, basic nature decreases. So see, this is very important question. They will give you cerium hydroxide, samarium hydroxide, terbium hydroxide, and then lutetium hydroxide. They can give any of these things, and they will ask you arrange the following in the increasing order of their basic nature. Arrange the following in the decreasing order of the basic nature. So that kind of questions they will ask you. For this purpose, you should definitely have idea on the what are the lanthanide elements. Next video only I will be creating the mnemonic and I will be uploading that one. So from that you can easily understand that thing. Clear? So in the lanthanide hydroxides, what is the basic nature? What is the reason for the basic nature of these elements? This is the reason. Now let's come to the other bases in the periodic table. Hope you have taken down this thing. I am rubbing this. Next, let us see the fifth group elements bases, 60th group elements bases, and then 70th group elements bases. You know, 70th group elements mostly they will be forming the acids. 60th group elements are having capability, as I told you now, no base is always base. Based on with which it is reacting, it behaves as acid or base. So that's why we are discussing the strength of these group bases also. 50th group elements bases are ammonia, phosphine, arsine, stilbene, bismuthine. The 60th group elements bases are H2O, H2S, H2Se, H2Te, H2PO will come. In these bases, they will be having the lone pair on them. So in these bases, the basicity is explained based on basicity is explained based on its capacity to donate lone pair. So basicity is explained based on its capacity to donate lone pair. If the lone pair concentration or lone pair is maximum, means that will be donated easily. Lone pair strength is minimum, means that cannot be donated. If you see lone pair donation capacity to electronegativity, and hence it is directly proportional to basic nature. If electron pair donation capacity is maximum, means its basic nature will be more, and it is dependent on the electronegativity. So that's why ammonia and water, which is a strong base, means ammonia is a strong base. Why ammonia is a strong base? Means nitrogen is less electronegative in nature, oxygen is more electronegative in nature, that's why it will not be donating. Come to the group ammonia, phosphine, arsine, stilbene, bismuthine. Among these, which is more basic in nature? Means actually this is very important question in the 10+2 examinations. Among ammonia and bismuthine, which is a strong base, and why? If you see, whenever you are moving from nitrogen to bismuth, the electronegativity decreases. That is one of the reason. When you are moving from ammonia to bismuthine, the size of the central atom increases. So the lone pair present on them can be happily accommodated on the atom. So it is not available for the donation. Since that is not available for donation, this will be more basic in nature. So why ammonia is more basic in nature? Means from nitrogen to bismuth, electronegativity decreases. That is one of the reason. Or from nitrogen to bismuth, the size of the atom increases, and hence the lone pair accommodation increases. So it will not be available for the donation, and hence this will be having the less basic nature and this will be having the more basic in nature. So like this we can cover the maximum bases that is possible from the periodic table. So basically, what is a base? How many types of bases are there? What are the hydroxide bases and what are the non-hydroxide bases? And what are the organic bases? What is the strength order for the first A group hydroxide, second A group hydroxides, D block hydroxides, and then lanthanum hydroxides, and then fifth A and then sixth A bases are what, and the strength order we have discussed. Take down this thing for 1 minute, and after that I will be explaining about the super bases. These are very important one. What are these super bases means? They are the strong bases. These are normally compared to the strength of these bases. Their strength will be very high. Mostly in so many reactions, to carry out the chemical reaction in a faster manner, we will be using those super bases. What are those super bases means? We will discuss. Take down these things. Hope you have taken down this thing. So I am rubbing this. Alright, next let us discuss about the super bases. Bases which are having the very strong nature are these super bases for which the strength is very high compared to the normal bases are known as the super bases. The best example for super bases are CH3Na, CH3ONa. This is sodium methoxide, sodium alkalide, not alkalide, no, sorry, methyl sodium, and C2H5ONa, NaSH. If you observe all these things, so see, CH3Na will break down into CH3 minus and then Na plus. CH3ONa will break down into CH3O minus and Na plus. One more is there, NaCN. NaCN will break down into Cn minus and then Na plus. CH3 minus will be coming from CH4. CH3O minus will be coming from CH3OH. Cn will be coming from the HCl. There is a rule that conjugate base of weak acid is strong. Conjugate base of weak acid is strong. This statement I will be explaining in the theories of acids. Now you just try to have the idea. Whenever there is a weak acid, if you remove proton from that, you will be getting the conjugate bases. Whenever you remove a proton from the acid, you will get a conjugate base. That conjugate bases are very strong in nature. That's why the reactions where they are involving, they will be super fast. That's why they are known as the super bases. The best example for super bases will be alkyl sodiums will be there, and then sodium methoxide and sodium ethoxide and sodium thiosulfide will be coming. Not sodium thiosulfide, no, sodium hydrogen sulfide is there, and then sodium cyanide will be present. And these are known as the, and alkyl lithium also there. CH3L methyl lithium. And you can use RMgX. This RMgX is known as Grignard reagent. This is known as Grignard reagent. Like this, we can have the metals reaction with alkyl groups, and metal reacts with alkoxide groups, and then Grignard reagents. All these are capable of producing the anions, which behaves as very strong bases. So that's why we consider them as super bases. So that is the thing about the what is a base, how many types of bases are there, what are the hydroxide bases, what are the bases other than hydroxides, and what are the bases of nitrogen family elements, oxygen family elements, what are the super bases, what are the D block elements, hydroxides, and what are the lanthanides, hydroxide. So that is the thing regarding these bases, and these all will give you idea about the foundation for bases. What are the different types of bases, that much you will be understanding. And in the next video we will be discussing about the theories of acids and bases. Thank you.